Today our topic is electronic configuration. We will discuss about electronic configuration and different rules and different methods of determining electronic configuration of elements. The arrangement of electron according to their energy level is known as electronic configuration simply. Okay, now we come to helium. Helium has atomic number of 2, so it has also 2 protons and as well as 2 electrons. So when you will put 2 electrons in helium, they will occupy K shell because K shell is the first shell, and in K shell there is only one subshell S, and S has only one orbital, and one orbital can occupy 2 electrons. So if helium has 2 electrons, they will occupy first shell, first subshell and first orbital, that will be 1s2. So how this happen, let's talk about that. Let's have a look at shell. First shell is also known as K shell, and K shell will have only one subshell, and if the shell is second, the second shell will have two subshell, that is S and P. And third shell, which is also known as M shell, and M shell will have 3 subshells. First shell have one subshell, second shell have 2 subshells S and P, third shell will have 3 subshell S, P and D. So S subshell will have only one orbital in every shell. Where there is S subshell, it contains only one orbital, and one orbital can have only 2 electrons. So S have one orbital, and it can contain only 2 electrons. In second shell there are 2 subshells S and P. Now P has 3 orbitals. P is a subshell and P has 3 orbitals, and S has 1 orbital. So totally there are 4 orbitals. So 4 orbital, if we multiply with 2, because every orbital can contain only 2 electrons, so when we multiply 4 by 2, that will contain 8 electrons. The same case with third shell. Third shell is also named as M shell, and it will have third shell. So third shell will have 3 subshells S, P, D. Now S contains 1 orbital, P contains 3 orbital, and D contains 5 orbital. Totally 9 orbitals are there in third shell, and we multiply 9 into 2, so answer will be 18. In third shell there are possible number of electrons are 18. It was the first method to determine how many electrons can be in a shell, or which shell contain how many electrons. That was the first method. If there is a question how many electrons in a shell, the answer will be just by a formula 2n square, where n is the number of shell. 2n square is used to know how many electrons can a shell have. So we use 2n square, and n has the value of number of shell. When also, let's suppose a question, how many electrons are there in third shell? How many electrons are there in third shell? We will use this formula 2n square. When we put the value of n, which is equal to 3, solution n is equal to 3, put in formula 2n square, what will be the answer? Let's guess. 2n square, 3 is the value of n, and when we multiply 3 into 3 is equal to 9, so 3 square will be 9, and 2 multiply 9 is equal to 18 electrons. So there will be 18 electrons in third shell. We can use this formula for any number of shell. This was the second method, that how to find how many electrons in a particular shell by using this formula 2n square. Okay, we have find out in third shell that how many electrons there will be, and we find that there will be 18 electrons. Now this is the first method of Bow method to put the electrons in a shell, subshell. So we will try to put the electrons in shell, and this is the first shell, this is the second shell. The first shell contains only one subshell, second shell contains two subshell, third shell contains three subshell, fourth shell contains four subshell, and fifth shell will contain five subshells, but here we will write only four subshells. You will find out why I have written four subshells. Aufbau is a word which means to build up, to set electrons according to their energy. First shell has the lowest energy, second shell will have higher energy than first shell but lower energy than third shell, and third shell will have higher energy than second shell but higher energy than second shell but lower energy than fourth shell, and fourth shell will have higher energy than third shell but lower energy than fifth shell. So energy will be from first shell to fifth shell, from lower energy to higher energy. So electrons first enter to 1s, then 2s, and then 2p, 3s, 3p, 4s, 3d, 4p, 5s, and then 4d, 5p, and so on. Here you will find the electrons will go first 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, and so on. Here we take an example of oxygen. Let's take oxygen. Oxygen has atomic number of 8 and atomic mass 16. Atomic number 8 tells us that it will contain 8 protons, and if an element contains 8 protons and it is neutral, then it will also contain the same number of electrons to neutrify itself. And when we minus the atomic number from atomic mass, this will tell us about neutrons. So when we minus 8 from 16, we will get 8, so there will be 8 neutrons. We have no concern about protons and neutrons, we have only concern about electrons. So we will take 8 electrons and we will try to put it in this manner in the oxygen element. So here we take 1s2, 2s2, and 2p4. 2 plus 2, 4, and 4 plus 4, 8. So oxygen has 8 electrons and they end up on 2p4. That's all. There are other methods and other problems with concerning electronic configuration, but today I will end up this video